The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, folks. Welcome back to another great episode of our Best Practice webinar series with 7Signal. If you could let us know where you're logging in from in the questions panel, we would love to know if you're tuning in from home, if you're in the office today, what part of the world you're tuning in from. I'm back in the Cleveland office, of course, and we have our special guest, Eric Muley, who's actually right across the office from me. How are you today, Eric?
I'm doing great. Nice to see you, Kelsey. Thank you.
You too. Long time no see. Thank you, Jim. He's also tuning in again from Cincinnati, Ohio today. How are you today, Jim?
I'm good. Thanks for asking. Good to be here.
Awesome. I see a few of you dropping in where you're joining us from. We have John tuning in from Massachusetts, working in the office today. We have another John joining us from home in Norway. Thank you so much for joining in. We have Keith from Louisville. Let's see who else we have here. We have Mark joining us from the office. We have Germond joining us again from Norway. Thank you for coming back, Germond. All right, if you guys want to keep dropping in where you're tuning in from, we would love to hear from you, and we will go ahead and get started. So we are 7Signal, the leader in wireless network monitoring, and we'll go a little bit more into depth as to what that entails and what our 7Signal mission is as a team. So we have a great topic here today, backed by popular demand, Wi-Fi 101, basic elements and troubleshooting and myths. And as I said, we are joined by our special guest, Eric, today, who is our Customer Success Officer. And we have Jim, who is CWNE number 183, and our Director of Global Wi-Fi Solutions. Thank you both again for being here today.
It's always a pleasure being with you, Jim.
And you, Eric. Thank you.
Awesome. And just as a reminder, I am Kelsey Rizzuto. I'm the marketing specialist here at 7Signal. Really excited to dive into this great topic today and learn a little bit more about these Wi-Fi 101 basics. So before we begin, a few announcements. These will look like reminders if you tuned in the past, but we do partner with CWNP for every single one of our webinars. So if you are pursuing a certification, by watching these webinars, you are eligible for CE credits. So if you're interested in that, just drop us a message in the questions panel or shoot us an email and we can get a certificate over to you shortly. We also do a product tour every single Friday at noon Eastern at go.7signal.com/tour. And we'll go ahead and drop that link in the chat here if you're interested in registering. But we don't go too deep into any kind of demo on these Wednesday webinars, but just to begin, we do have some exciting updates with our products. We announced 2 weeks ago our release of Mobile Eye for iGel Linux. We also recently added enhancements to Sapphire Eye over-the-air mode. And I think this past month we announced the release of a portable Sapphire Eye sensor. So some exciting updates here. If you haven't registered for a product tour recently, maybe a good idea to do so just to keep up with everything that's going on. Moving forward, we do also post all of our archived webinars to our YouTube channel at 7Signal. So today's broadcast will also be up there later this afternoon if you want to go back and rewatch some really good insights that we've covered. We are also very active on our Twitter account, so go ahead and give us a follow at 7Signal. We also post our slides from every single webinar there today, and those will also be up this afternoon as well. But if you're not active on Twitter and you want access to those slides, no problem. Just drop us a message and we can email those to you via request. Another reason to follow us on Twitter is because we are very, very active on there, and we also provide a lot of merchandise and 7Signal swag to those who follow us and engage with our trivia questions during these webinars. So I'm going to go ahead and read last week's lucky winners. We had Paul Adams, Dermot Allen, and Jeff Courtney. So congratulations to you three. You should be receiving possibly a 7Signal mask, a hat, in the mail soon. And for the rest of you on the line today, if you're interested in receiving that kind of merchandise, stay tuned and get ready for our trivia question later on.
Kelsey, is it a surprise what they'll receive? It's like, a grab bag, or what is it?
This week, it may be a surprise. We just recently got in a ton of 7 Signal masks, but our hats are also a crowd favorite. So we'll go ahead and wait
Okay,
and see.
nice.
One more announcement before we move forward. We were recently recognized in the Gartner 2020 Market Guide for Digital Experience Monitoring. Gartner has recognized 7 Signal as a representative vendor for Mobileye. We're really proud, really excited about this. And again, we'll go ahead and drop another link in the chat here so you can go ahead and check out this report if you're interested. All right, on with the show here. So a little background and history on 7 Signal. We were established in 2007 in Helsinki, Finland, and we're now located in Cleveland, Ohio. We've hit a lot of major milestones along the way. We're really, really proud of the 1 billion data points we're analyzing daily, in addition to the 5 million devices we're monitoring daily. We have over 200 customers, over 30 partners, and 14 patents, which goes to show that the technology you see from 7 Signal, you are only going to see from 7 Signal. In addition, we are certified in over 40 countries, and we are GDPR compliant, which ultimately means that we take data and privacy very, very seriously for all of our users across the globe. As I said, with 7 Signal, we are the leader in wireless experience monitoring, and we're here because the digital experience matters, and it's largely related to Wi-Fi and connectivity. So what we're able to do is provide full visibility into the end user experience through an outside-in approach through our platforms of Mobileye and SapphireEye. We're also completely AP and device agnostic, which goes to show that the great tools, great technologies you already have installed, we're incredibly complementary with those as well. So usually when you're experiencing connectivity issues, it bubbles up to one of these top 7 Wi-Fi problems here on the left, such as congestion, coverage loss, co-channel and radio interference, and more. And how we're able to detect those through that outside-in approach, as I mentioned previously, is by running active and passive tests on the edge of the network, looking for things like throughput, packet loss, adapter and driver issues, and more. So to give you a little bit more insight as to what makes us so different, you've already got those great tools, great technologies installed on that typical enterprise LAN infrastructure, such as your Riverbed, Cisco, Aruba, Appneta, and more. But what 7 Signal does with Mobileye is picking up where those leave off, giving you full visibility into the end user experience as well. Mobileye can be installed on ultimately any mobile device, from your laptops, your mobile phones, Zebra scanners, workstation on wheels, and more. And Mobileye can be installed on any macOS, Linux, Android, or Windows device as well. We additionally have SapphireEye, which are our sensors for service level quality and RF visibility, giving you full perspective into what is occurring in your wireless network environment. But what we can do, taking it one step further, is give you that visibility into those external home networks. For example, I'm in the office today, but a couple of days a week, I'm at home. So giving you that visibility into your home work environment, if you're in a house, if you're in a multi-tenant apartment, giving you kind of that reliability and perspective in the midst of a really unprecedented time here. And as I've said before, work from home is here to stay. And as I can see, a lot of you tuning in today are working from home. And when it comes to that work from home environment, it's not only about having Wi-Fi just because it's nice to have connectivity, it's mission critical. And you need to stay productive and connected to your work no matter where you're tuning in from. So in the midst of all this, we have done a give back. Mobileye offer 50 devices for 50 days, and we'll go ahead and drop that link you see up here in the chat as well, so you can go and check that out and see what there is to offer. All right, then, on with the show. As I mentioned, we do trivia every single webinar here, so I'm going to go ahead and launch a poll that Eric provided for us. And let's see what we got here. Can you guys see this question?
Yes, indeed.
All right, here. So what is the top issue with Wi-Fi networks? Okay, I see a lot of you dropping in your answers.
Jim, any predictions?
Well, these are all real issues with Wi-Fi, particularly in the enterprise. It'll be interesting to see what our audience says are the strongest or worst issues they have to deal with.
Yeah, absolutely.
Pick your poison.
Right.
All right, here I see a few of you dropping in some last minute answers. So we are going to go ahead and close the poll here. And Eric, how did we do?
I think we did pretty well. It's good to see our audience is in the know with regards to the top problems. Other Wi-Fi networks, indeed. We're going to really dig into this today and make sure that our audience really understands what they're up against when trying to provide great digital experiences for people. So roaming is a big problem, and we're going to talk about that today as well, but they nailed it, Kelsey.
Awesome. Sounds good. Well, thank you all for participating. We may get some 7 Signal merch sent over to some lucky winners soon. So on with the show, I'm going to go and pass the controls over to Eric here. And Eric, you can go ahead and start sharing your presentation here.
All right. How does that look?
Awesome.
Okay, awesome. Let's go. So with our presentation today, it is a Wi-Fi 101. So what that means is that a lot of you out there who are in the field, you're going to hear some things that you've heard before. But what's neat and interesting and fun about this session is that we try to break it down and explain these topics in a way that anybody can understand. So even if you understand them, you might find it fun and interesting to try to explain these topics to others, either your colleagues, your coworkers, or even your family members. And so we try to use a lot of analogies and we use a lot of pictures in order to help achieve that goal. Okay, so let's get into it here. Understanding just the absolute basics of Wi-Fi, why it works, why it doesn't work is really important because it can be very, very frustrating. Many times in a lot of organizations, we point the fingers at one another. It's a wired issue. No, it's a wireless issue. No, it's a device issue. And by understanding how Wi-Fi works and how it doesn't work, we really can point the finger in the right direction and eliminate everybody's frustration. There's nothing worse than somebody complaining about a poor experience, and then you go and look at the Wi-Fi network and you don't see anything wrong, okay? And the point here is that we can't see Wi-Fi. So it's kind of a mystery, all right? It's like magic to a lot of us. But we're gonna unlock the mystery today. It's not magic in any way, shape, or form. And so, the ace of Wi-Fi here is nothing to be afraid of. So let's just dive right into it and dispel some of the myths right out of the gate. Wi-Fi is radio. It's radio waves. So just like how you tune into your FM dial 97.5 to listen to classic rock or whatever it is, it's the same principle. It's the same concept. Now, with radio, okay, as you know, there are frequencies that are licensed and there are frequencies that are unlicensed. So a licensed frequency means that only you are allowed to broadcast on it, like 97.5, classic rock here in Cleveland. Okay, now if the FCC monitors these airwaves pretty closely, these frequencies, in order to make sure that if you're paying to broadcast on a certain frequency, that only you broadcast on that frequency and nobody else is allowed to do that. Those are licensed frequencies or licensed bands of spectrum, okay? Now, there are some bands of spectrum out there or frequencies that are free for anybody to use. And that's where Wi-Fi lives. Wi-Fi resides on these two bands of spectrum, what we commonly refer to as the 2.4 gigahertz band of spectrum, as well as the 5 gigahertz band of spectrum. Think of these as like two little highways. Okay, and on the highway, that highway has certain properties, and you're allowed to drive on the highway following certain rules. Just like how when we go to work in the morning or when we go to the store, we have to follow certain rules when we're on the road, like staying in our lane, not going too slow or things like that. It's the same thing with Wi-Fi. Now, just to nail down this point with regards to frequencies and stuff like that, I wanted to show you what we're up against here. This is the United States frequency allocation chart. I mean, this is crazy. There are so many slivers of spectrum out there that the FCC regulates very, very carefully and very closely. This is like where your cell phone carriers operate, your TV broadcasts operate. They have to make sure that people are not stepping over one another, shouting over one another. And so it's monitored very, very closely. Now, what's really interesting about this diagram is that what you have, okay, is right over here, you've got your 2.4 gigahertz band. Jim, can you help me out here? Can you even see it on here? It's probably where my mouse is, right here somewhere. Is that right?
Yeah, I'm zooming in. I've got my 4K monitor, and it's still hard to pick it out. It's pretty tiny.
It's the tiniest of slivers that they've allocated for free for us to use. That's 2.4. And then if you come over here, somewhere in here, is that about right, Jim? This is where 5 gigahertz is, or maybe it's over here a little bit.
Yeah, that's right. And one of the things you'll notice about the 5 gigahertz band is that there's multiple users in the same frequencies. So
that's exactly right.
There is unlicensed usage, which Wi-Fi can use, and incumbents that we have to avoid when they're present as well.
That's right. It's really critical. These are some of the, when you become an expert, you dive into the more advanced elements of Wi-Fi, you learn about how, we need to share the air properly with one another and what the restrictions and limitations are and how it works. And we're going to just touch on that a little bit today. But guys, I just wanted to show you this picture because it is amazing how much is going on in the air that we can't even see. Okay, these are the big 4 topics that we're going to talk about today, or we'll take them on one at a time. And by the time we're done in about 30 minutes or so, you will have a good overview, basic understanding of these 4 topics, why Wi-Fi works and sometimes when it doesn't work. All right, so let's do it. First thing we're going to talk about is congestion. In order to understand congestion, also sometimes referred to as contention in Wi-Fi speak, you have to understand channel planning. Okay, so if you recall, a few minutes ago, we said that these bands of spectrum are like highways. And if 2.4 and 5 are highways, then those highways have lanes. And those lanes are like channels. For 2.4, you really only have 3 lanes on the highway. And those would be channels 1, 6, and 11 that you see right here. Now, granted, there's channels 2, 3, 4, and 5, but we don't like to use them because they overlap with 1 and 6. So 1, 6, and 11 are the 3 non-overlapping channels that you should use and not use any other ones. Sometimes when we're at home, we think to ourselves, oh, well, if I've got people on channel 1, then I'm just going to go on channel 2. This is a no-no. Okay, when you overlap channels, it'll cause collisions in the air when people are transmitting on those channels simultaneously. Those collisions are going to lead to retransmissions or retries. And when you have so many retries clouding up the air, okay, this is potentially going to increase channel utilization. It's kind of like create like a rush hour traffic where, there's just a lot of cars on the road and not a lot of room to move. It can also lead to a stepping down or a slowing of data rates when there's so much contention going on in the air like that. So on 2.4, there's very low capacity. It's a 3-lane highway, which is why we try to move people onto the faster highway with more lanes, and that would be the 5 gigahertz highway. Now, depending upon where you are in the world, there could be as many as 24 non-overlapping channels. That's like having a 24-lane highway, and we promote using as many of those as you can, spread out. You know, when you're on the highway and there's nobody in that lane, get in that lane so you can go a little faster. And so we want to promote that. Now, one of the things that you can do in 5 gigahertz, which is pretty popular, is channel bonding. You can take 2 of these channels and you can bond them together to kind of make a super channel that allows you to go really fast if your device is capable of going really fast. Okay, there's no point in creating a super lane on the highway if you're driving an old beat up jalopy that can't go very fast. But if you drive a Ferrari, then driving on one of these lanes might be a lot of fun. Basically, by doubling the size of the channel, you literally can double your throughput. Again, if your device is capable of doing that. So this is HT40, or high throughput 40 megahertz wide channel. Over here on the other side, you can see that we've bonded 4 channels together in order to create a super massive fast lane on the highway. VHT80. Jim, can you clue us in on what VHT stands for?
Yeah, happy to. So high throughput HT, that's actually the official name of the 802.11 amendment. And then VHT is very high throughput. These are extremely technical terms. And that's the name, that's the actual name of the 802.11ac amendment.
That's fascinating. Okay,
Yes.
so we have the high throughput, and let me make sure I've got this correct, and the very high throughput.
It's true.
Okay.
And Wi-Fi 7 will be EHT. Any guesses as to what that means?
I'm going to go out on a limb and say extremely high throughput.
That's exactly right, actually. Very technical speak, maybe a little bit beyond the basics here, but yes.
Okay. Well, yeah, this is Wi-Fi 101. We want to keep it simple for folks, so thank you for that clarification. Now, the one thing that I'll say about this whole thing here is, remember, we said that this is only a 3-lane highway up here, and that those lanes can fill up pretty fast, and then it's going to, like rush hour traffic, you know, you run out of lanes, you got too many cars, everybody's going to slow down. When you bond channels together like this, you could potentially run into the same issue. So just be careful. Be careful when you do it. Okay, it may be necessary in some environments to do because you need that speed and that throughput, but in other environments, it's not necessary at all. Like in a stadium, for instance, where you've got high density, you need all of the channels that you can get, so you would not want to do this kind of channel bonding and cut down on the total number of available channels, okay? Now, there is something exciting that's actually happening in the very near future, and that is that the FCC has decided that because Wi-Fi is actually just taking off and exploding the way it is, that they're going to open up a whole new highway, a whole new band of spectrum, and that's going to be the 6 gigahertz band of spectrum. So whereas 2.4 offered us just this little bit of capacity right here, a 3-lane highway, 5 gigahertz, you can 20 megahertz wide channels, it says 25 here, okay, again, depending upon where you are in the world. And down here, the 6 gigahertz band, it's almost double the amount of spectrum that is available to us today. So this is really, really exciting. And I'm particularly excited about the channel bonding that you can now do here. Look at all of the 80 megahertz wide channels that you can actually have without any overlapping taking place once we move to 6 gigahertz. And 6 gigahertz is going to be called Wi-Fi 6E. Okay, not to be confused with Wi-Fi 6, which is a protocol, okay, which is a new moniker for 802.11ax. This is called Wi-Fi 6E, and 6E represents this extended spectrum that is going to be available to us in the near future. Hey, Jim, any insights as to when we can expect 6 gigahertz to really truly be available? I mean, it's going to require 6 gigahertz radios in both devices and access points. Any insights for us?
Yeah, so we need those two things. And in other countries, they're spectrum regulators, so they're equivalents of the FCC, still have to release spectrum. So we've got the spectrum released in the US, the UK, I believe Korea, maybe Brazil. I know Brazil was working on it, and other countries have to follow suit before they can access it. And some of them don't have as much spectrum available. But as far as products on the market, we'll see consumer products out in the next month or two in the U.S. And then in the enterprise, where we need more features and more reliability and overall better products, we'll see those next year.
Wow,
Just
that's really exciting. Yeah. That's really exciting because, I mean, look how much additional capacity is going to be. I mean, literally everybody should be able to spread out and go really fast, right, Jim?
Yeah, and those, troublesome 80 megahertz channel widths that we'll talk about and 5 gigahertz will be almost a non-issue, at least in the US, where we have so much available spectrum in 6 gigahertz.
Yeah, this is really exciting stuff. So be on the lookout for that. It's called Wi-Fi 6E, and I think the E stands for extended. Is that correct, Mr. Vada?
That is correct.
Okay, another technical term for us. Okay, got it. So here we go with just understanding and using the analogy one more time for you before we move on to the next topic. And we continue to go back to this analogy of the highway. The highway has lanes. Okay, and when you have lanes on the highway, those lanes can only handle so many cars before it just starts to slow down. Now, this image here I really like because it is a great example of very poor channel planning, very poor highway planning, in my opinion. As you can see here, Jim, we've got this diamond lane, which is the high occupancy lane or the carpool lane, and it's completely empty. Nobody's using it. All right, and as a result, you've got all of these cars over here who are going slow. This would be bad channel planning from a Wi-Fi perspective. What you would want to do is open up this lane so that everybody can spread out and go fast, okay? And then let's just take another little snapshot here. So for instance, if you have a situation where it seems like everybody's gathering on one side of your office, okay, and so it's just, maybe you've hired a bunch of people, or maybe this is where just a lot of people find themselves sitting or gathering, or maybe you've got some conference room, you can run into a situation where one lane on the highway is just not going to cut it anymore. Okay, you gotta construct another lane on the highway and split the traffic between those two groups. So maybe you've got one on one side of the suite, another one on the other side of the suite, but the point is that those channels fill up fast, full of clients. Those lanes fill up fast, full of cars. And they need to widen the highway sometimes. And so you would do that by adding a lane, by adding a channel. Okay. All right, we're going to move on to our next topic, and we're going to talk about propagation. This is really important to understand. Because just because we have Wi-Fi router or access point turned on does not mean that those frequencies can just travel forever. Okay, they will peter out after a period of time, and the low frequencies can travel farther. Okay, you see the big sine wave up here. These can travel farther than the higher frequencies, which are more like these milliwaves that peter out more quickly. Okay, now they are traveling at the speed of light, so as soon as you turn these radios on, they're broadcasting and you should be able to get them. But it's really important to understand how the lower frequency, in this case 2.4, is different than 5 gigahertz, the higher frequency. So here's a quick example of what we're talking about here. If you had an access point in the middle of your floor, maybe one radio was dedicated to providing 5 gigahertz service, which we like because remember, 5 gigahertz is, it's less crowded, more lanes on the highway, can go really fast. 2.4 on the other radio, and that's providing service as well. As you can see here, the propagation circle, the cell size is sometimes we call it, for 5 gigahertz is much less than 2.4. And this isn't to scale or anything, but it's just to give you an idea of how far the signal can travel. And so this person right here in the middle of your screen is on the 5 gigahertz network, maybe taking advantage of some of those high, fast data rates. And then you got these people out here who are relegated to 2.4 because their devices can't hear. They're too far away. They can't hear the 5 gigahertz signal. And then you've got this guy right here. Now, Jim, let me ask you a question. If this little guy right here, stick figure, had a laptop computer, which network would his computer or her computer latch onto, 2.4 or 5? Can you let us know?
Yeah, it really depends on the device itself.
That's right. The point is that we don't know.
Yeah.
Yeah.
That could be a really long answer, but yeah, it's really uncertain.
The point is that it is uncertain. This person's client device is actually going to make the decision as to whether it decides or wants or desires to latch on to the 2.4 network or the 5 gigahertz network. He's right on the edge, okay, and not necessarily the edge of glory right there. It could be, you know, the edge of doom. If they latch onto the 2.4 network where a slower, more congested experience awaits. So what we want to do, if we want everybody in the building to have a 5 gigahertz experience where everybody can spread out and go fast, then we may need to add more access points and create more of these small cells. That way, when you walk from one side of the building to the other, you continue to have a great experience. And then the 2.4 network almost becomes kind of like a lifeline network, or maybe for people like this guy right here, who's out on the porch at the picnic table, maybe having some lunch. At least they have some kind of coverage. Now, this is a really important question. Why does your radio cut out when you drive under a bridge? Well, it's because of barriers to propagation. These radio signals, they can't cut through every single surface. They don't have a problem getting through wood or glass. And a lot of our buildings are like that with sheetrock, no problem. But there are two surfaces that we really need to be on the lookout for with regards to our environment, and that's concrete and metal. With concrete, like this bridge that we're seeing here, the radio waves are basically going to be absorbed into the concrete, and they're not going to be able to really penetrate and pass through. Now with metal, it's the opposite. It's going to reflect. So you may have a big metal filing cabinet between you and your router, and you think that the signal should be able to get to you just fine. And it can, because it's just bouncing around you, or not, it's bouncing back to itself and not getting to you. So when you're in your homes, you need to look around the environment, see what's going on. I got a great example of my dad called me up and talk, you know, for the hurricanes and such and the high winds. And he said, Eric, I don't understand. I'm sitting in the next room over, okay, and the router is right around the corner in the bedroom, and I'm in the living room, and I can't get a good Wi-Fi signal. Why is that? And I said, well, Dad, it's because of barriers to propagation. You live in a house where the interior walls are made of concrete block. And so the signal isn't getting to you, even though it's, you know, literally 10 feet away from you. You got to go around the corner. So with that said, I recommended that he either move his router out into the open, or he get one of these mesh networks where you put these little base stations around the house that can all kind of communicate with each other. And, you know, in doing so, you're able to get more coverage in the house. Okay. So that is propagation. You got to understand how that works, because the signal just might not be going as far as you think it is, based upon where you are sitting and where your router or access point is. Okay, so the next topic we're going to talk about is interference. And because we're talking about radio, you know, another word to describe interference is noise. Okay, think of it like this. You're listening to your favorite radio station, 97.5 classic rock, and you're enjoying it. Then all of a sudden somebody comes along and they start playing their radio. And then somebody else comes along and they start blaring their radio. And now all of a sudden you've got this garbled mess where you can't hear your favorite song anymore, okay? This is kind of like what 2.4 gigahertz band looks like, with a lot of people chattering and talking and playing music and playing. Makes it really hard to hear what's going on. And if your device can't hear your access point, or if your access point can't hear your device, if the message doesn't get through clearly, then it's going to lead to a retransmission or a retry. And it's basically like, what? What did you say? Can you say that again? Can't hear you. And all of those retries and retransmissions, that's going to once again lead to more congestion and also potentially a stepping down or a lowering of data rates where everybody's going to start to go slower, okay, because of all of that noise in the air. Either the device or the access point just can't decode the bits because of all of this interference. One of the temptations is let's just turn up the volume and scream and talk louder. Okay, and this is like a concept that maybe you've heard of before, where if I just turn up the signal, then I've got enough signal to overcome the noise. Okay, SNR, signal to noise ratio. And this is not necessarily a good practice though, because if you turn up your radio, then this person's going to turn up their radio, and then she's going to turn up her radio. And before you know it, you're right back where you started, where it's a big garbled mess again. Okay, so that's why planning and designing networks is so critical, okay, in the enterprise. And even when you're at home in a multi-tenant apartment building or a condominium complex, or if your neighbors are really close together, this can be happening where there's this Wi-Fi noise all around you interfering with your ability, and you can't see it, so you don't even know it's there. Okay, and this is like gets back to our trivia question. So what you really want to do is move someplace when this situation takes place. You want to go someplace quiet. So for example, if you are at a restaurant, it's kind of noisy, what do? You can't hear your friend. You say, hey, you know what? Let's go step out onto the deck. Let's go outside and talk. Let's go sit outside. And we do that because it's more quiet and there's not as many people and it's not as noisy. And that's the equivalent of moving from 2.4, which is really crowded and really noisy, over to 5 gigahertz, where it's a lot less crowded and a lot less noisy, okay? So getting back to my example here, this is basically what it's like. You've got the 2.4 gigahertz band on the left, which is like going into a crowded, noisy sports bar, which hopefully we'll be able to do it one day again, where we're cheering and we're yelling and we're screaming, and it's really hard to hear the person next to you, okay? And that's why when we see people who are on 2.4, in order to have a better Wi-Fi experience, one of the first things that we recommend is, okay, can you move on over to the 5 gigahertz network? Is your device capable, and is your router capable? And today, most are, so that shouldn't be a problem. Now, over here on this is Jim. Is this you and your wife having a lovely time together at the restaurant here? Nice and quiet and communicating nicely and clearly to one another? Looks like it.
Maybe a long time ago before we had kids. That's what it was like.
Wonderful, wonderful. All right, so that's propagation. Or I'm sorry, that's interference. Now, there are tools out there that you can use in order to identify this interference. And so, for instance, over here, this is one of our 7 signal systems that we're using here to identify all of the noisy neighbors on 1, 6, and 11. Look at this. So each one of these arcs represents a radio, a Wi-Fi radio signature that that 7 signal can hear. And look at them. They're just, all of these networks are stacked on top of one another. This is a prime example of 3 lanes on the highway just filled up with cars and everybody's going slow. And we call this co-channel interference. Co-channel interference. Now look over here. Okay, so not as many, but they're all overlapping. Over here, you had everybody staying in their lane. Over here, this is the equivalent, when you see this overlapping, this is the equivalent of people swerving into your lane. Whoa, what do you got to do? You got to tap the brakes before you get into an accident. It's a very similar concept, okay? You don't want to have collisions, but that's exactly what's going to happen here with the little bits that are traveling over the air, and it's going to lead to those retransmissions again. Okay, so everybody's got to stay in their lane. Okay, 1, 6, and 11. Okay, these channels here, we know on channel 5 and channel 4, this is bad news. This is more of what you're looking for. Okay, there's just a couple radios out there. They're on 1, 6, and 11, And, you know, there's no overlapping and it's not too crowded either. Everybody should be able to drive the speed limit and get some good action. There is some of this noise on 5 gigahertz networks too, and this is why I'm very excited about the new 6E spectrum being released, is because if you look over here at 7 signal corporate, there is a lot of overlapping taking place. There are a lot of noisy neighbors, and really what we're looking for is something like this. Okay, these are your bonded channels, and then this is kind of like one of your little skinny 20 megahertz wide channels. This is an 80 megahertz wide channel. Okay. Now, this is a little bit of an advanced topic, but there are some situations out there where controllers will fluctuate the channels and fluctuate the power automatically. Okay, we call this RRM, or radio resource management. I'm really proud of this animation that I created here, Jim. Now what happens?
Yeah, this is PowerPoint, just excellence.
Yeah, thank you. Appreciate that. Now what can happen, unfortunately, is that, you know, sometimes it works well and sometimes it doesn't. And you can have a situation where you've got 3 neighboring access points all on the same channel now, like what we see right here. Now this is the equivalent, Jim, of basically a 3-lane highway, and now here come the orange barrels. Yikes. And now everybody's forced to squeeze into 1 lane on the highway. What happens? Everything slows down to a grinding halt, doesn't it? And so that's why we need to be on the lookout for this situation. Okay, again, more channels, more lanes. We need to spread out so that we can go fast.
Yeah, and you would think that those automatic channel algorithms would just figure this out and not do silly things like that. And yet, we frequently see that they do.
Yeah, it is
We
true.
need to keep an eye on it.
Yeah. Yeah, indeed. So last topic, we're going to talk about devices. A little bit ago, we talked about how important devices are to the overall equation, that devices are the ones that actually choose whether they're going to stick or they're going to roam, or whether they're going to choose 2.4 or 5. And so what we like to do here is play a little game. Which would you buy? Okay, so Jim, if all things were equal, if these 2 laptops were identical in every way, except for in terms of price and everything, you would look at these 2 here and you would see, you know what, if I'm looking to buy a laptop for my coworker, or maybe for my spouse, or maybe my kid for school, for Zoom school, you might look at this, Jim, and say, you know what, I'm going to go with the one with the faster processor. Might you make that determination, Jim?
Yeah, yeah. If they're priced the same, that i5 processor will be a lot faster than the i3. Easy choice.
Right. Yeah, easy choice. Unfortunately, Jim, you would have chosen poorly. Okay, because the wireless LAN adapter in this radio, or in this laptop right here, has what we call a BGN adapter. Okay, and a BGN adapter is not even capable of getting onto a 5 gigahertz network. So you better know your Wi-Fi standards. And what you want to do when you're shopping for a laptop computer is look for the letter A. The letter A is the amendment to the 802.11 standard that supports 5 gigahertz. So you, by getting a BGN, and they still sell these things today, don't they, Jim? I mean, I think it should be a crime, but they're out there.
Yes, it's a 7 signal crime for sure.
Yeah, it's a crime in our penal code. Over here on the left, you see this one has an AC adapter. It has the letter A, no problem. Maybe if it said AX, okay, that's even the newest standard, AX, it has the letter A, that would be fine. You could buy that one too. But be on the lookout, because the Wi-Fi Alliance, in order to help people with this alphabet soup that we have here, the A, B, G, N, and all this stuff, is that they've come up with some new nomenclature. So the new standard Wi-Fi 6 is a new name for 802.11ax. So if you see something that says it has Wi-Fi 6 in it, you're good. Even if it says it has Wi-Fi 5, you're still good, because Wi-Fi 5 indicates 802.11ac. Okay, so you're good to go. Now don't get Wi-Fi 6 confused with 6E, which is Spectrum. Okay, just because your laptop has Wi-Fi 6 doesn't mean that it can operate on 6E Spectrum. Okay, because remember, we're talking about frequencies here. Okay, a 5 gigahertz radio cannot communicate on a 6 gigahertz network. It's just not possible. All right, so this is it, guys. Know what it takes. It could be something going on in your environment. It could be something with your device where your device just doesn't have the capabilities of going fast. Could be your ISP. It could be your router. Your router is really old and slow, and it's not capable of going fast, even though you've got an awesome new, Lamborghini or Ferrari. You can't take that thing on a country road. It's not going to work. You're not going to be able to go fast. And these are the big four things that we covered today. It's devices that make roaming decisions. Look at adapters and drivers. They need to be up to date, and you hope that keeping them up to date, they'll be capable of taking advantage of the fastest speeds and making the best decisions. Coverage. A lot of people, they're working upstairs and their router is downstairs. You got to get closer because of barriers to propagation. And then we talked about congestion. Or contention, where if there's too many cars on the highway and not enough lanes, everything is going to slow down. So you need to kind of switch lanes and get into a lane that's less crowded. And then finally, interference. Wi-Fi is the biggest interferer of Wi-Fi. There are noisy Wi-Fi signals all around you. And you use tools in order to see where they're coming from so that you can go someplace quiet. And there you have it. We did it. Jim, what do you say?
Nice
Basic
job.
Understanding? Yeah.
Yeah. Just half an hour, got all the basics in, and hopefully a lot of questions, and curiosity came from that.
Yeah, exactly. Kelsey, if you're out there, is there a question or two that we can do in the time that we have remaining?
I believe so. We got a couple of questions just as a reminder for those of you who do want access to the slides and the recording. We'll post this to YouTube later, and we will be posting the slides on Twitter as well. Let's see here. I see that Jim has been really active answering a lot of great questions that we have already gotten in the chat here. Let's see what else.
Yeah, one that came up a couple times was about our channel chart for 6 gigahertz. So Eric, maybe you can go back to that slide where we showed all the available channels in 6 gigahertz. A couple of people commented that it looked like there were only 7 channels available. And this is what we were talking about. So when you look at that 6 gigahertz band, the first row is the number of channels that are available in a 20 megahertz channel width. 59 channels. The number 7 at the bottom is if you use the widest channel width available, which is 160 megahertz. Those channels are wider, so we can only have 7 without overlapping. And so we were talking about there being 14 80 megahertz channels because that's how many fits into the band without any overlap.
Yeah, it's actually kind of exciting, just the possibilities for just really going fast, depending upon the use case. A lot of people don't have to go that fast. They're just, using Netflix or whatever. But in certain environments where you really need incredibly high speeds in order to transfer really, really huge files, I can see where that could be, like laboratories or whatnot, that could be really valuable.
Yeah, another comment here from Mark, which I like. He said, and I think this came when we were talking about being, turning the power up on your APs and trying to be louder than your neighbors. He says, having signal does not mean performance. I think there's a lot to be learned from that. Even with a quiet signal, if your noise is really low, you can have a very good signal, very good performance as well.
That's a good point. That's a very good point. It's that ratio that is the key. Do I have enough signal to overcome the noise in the environment? And one of the numbers that we throw around is 25 dB difference between the noise and the signal. So like you said, you could be kind of far away, but as long as there's enough signal and not a lot of noise, you can still have a good Wi-Fi experience, right, Jim?
That's exactly right. That's exactly right. And Wi-Fi is very sensitive to noise, especially other Wi-Fi networks. So even a quiet Wi-Fi network will cause interference with your network, no matter how loud you turn up your transmit power.
That's right, because of just how the protocol works, where it's, it's a very polite protocol, meaning that if it hears something, it's going to back off, even if it hears it kind of faintly, right?
That's right. Yep.
So, All right. Anything else out there, Jim or Kelsey, that we can answer in the few seconds that we have remaining?
Yeah, Antonio, maybe one last question. Is it recommended at this point to use 20 megahertz channel width in 5 gigahertz and forego 40 megahertz channel bonding for better channel reuse?
Depends on the use case, right? We talked about the high density in like where there's tons of people. You need all the channels that you can get, right, Jim?
Yeah, that's right. In a high density network, generally you just want to use those 20 megahertz channels, including those yellow ones in the middle that are DFS, that have DFS rules attached to them, and avoid the co-channel interference from your own APs. So even though using 20 megahertz means it's a little bit slower for that single AP, the net system performance of the whole Wi-Fi network will be greater.
And we've actually seen a lot of successful 40 megahertz wide channel plans in enterprise environments. So it is certainly, as you can see here on 5 gigahertz, I mean, you can have up to 12 non-overlapping channels here with the DFS channels, and you should be able to design a channel plan where you've got the wide channels, very little overlapping. We've seen a lot of success with 40 megahertz wide channel plans, haven't we, Jim?
Yeah, we have. Yeah, and so the sort of approach, if you wanted to give it a rule of thumb, is sort of use 40 megahertz until you can't, right? If you have too much CCI from a 40 megahertz channel plan, then bump down to 20.
Yeah, and I'll tell you what, I mean, you can go plenty fast on a 20 megahertz wide channel. So it's not the end of the world either, is it?
That's
all right. Well, I think, Kelsey, we're out of time. I want to thank you for setting this up and helping us kick it off. And Jim, it's always a pleasure working with you. So thank you very much.
good to be here. Thanks, guys.
Of course. Thank you, Eric, and thank you, Jim. Thank you to all of you for tuning in today for this great webinar on Wi-Fi 101. We also posted the link for next week's webinar, if you saw it in the chat panel here, where we will be with Germond Ration, who actually had his Wi-Fi airtime calculator featured on our previous Keith Parsons webinar. So if you're interested in that, go ahead and register, and we'll hopefully see you next week. Thank you to all of you.
Thank you.
Bye, guys.
Thanks, guys.